Hey everyone, Mr. K here, another programming video, and this time we're doing while loops. This one should be a short one. While loops are pretty basic and straightforward, there's not much to them, and they're pretty handy. So, previously we talked about recursion, and this is a recursive method of doing what I want to do up here. And the way recursion works is it basically just calls the same method. It calls itself again, just with a slightly different argument. Excuse me. And what it eventually does, it calls itself so many times, and eventually this gets whittled down to where n is less than 0, and it basically bails out and finishes itself off. It's like copying and pasting. It's taking the method, copying and pasting, and doing it again, copying and paste, doing it again, repeating over and over and over again. While loops are a bit different they essentially accomplish the same thing, this repetition. But the difference is, as opposed to calling itself again, you're here, you go through the lines, you get back to the end, and then you go back to the beginning. That's it. You just loop. This is literally a loop. It loops around. Recursion is just repetition. While loop is essentially a loop. It just loops. And there's other loops out there too, but they all basically function the same way. They check something and then they do whatever's in between and do it again, check again, do it again, check again, over and over and over again. As far as which one to use, I know I haven't even talked about how these work yet, but as far as which one to use, while loops versus recursion, it doesn't matter. Whatever makes the most sense. Okay, if it gets the problem solved, it gets the problem solved. It's not a big deal which one you use. All right, it has to work. That's what it basically comes down. It has to work, and it has to be efficient too. So this is just another tool in the tool belt. So how do they actually work? Well, they start off with a test case. It checks to see if some variable is something, in this case greater than or equal to 0. If it is, run the code that's in between your braces. Here we're printing out what n is and then decreasing n by 1, and this is important. We'll talk about it in a little bit. And then there's the end of the curly braces. Go back, test it again, and it will keep testing and testing and testing. And as soon as this fails, as soon as we hit negative numbers, this doesn't happen. All right, so it will do 3 and 2 and 1. It'll do 0, but as soon as negative 1 hits, this gets skipped and it goes right to blast off. So I actually have it down here. I ran it once already before I started recording. Called it with 10, 10, 9, 8, 7, 6, all the way down to 0. Negative 1, even though a negative 1 got punched in here, this failed. So this doesn't run, we go print blast off. Okay? Simple as that. This I mentioned was important, and I will show you why. 10, 10, 10, 10, 10, 10, 10, 10, 10. Yeah, it's an infinite loop because n is always going to be greater than or equal to 0. And in case you don't have a print statement inside your while loop to see that it's repeating over and over again, this is a big key if you're using Eclipse, is the fact that the stop button is on, which, well, you can active? I don't know. Yeah, that means your program's in an infinite loop. Something is going on, and that does happen even in the best of us because you just miss something. So make sure, typically what you need to do is you need to have something in here that's tweaking a variable so that when you run it again, run the loop again, it's getting closer to eventually finishing itself off. Okay. I got one more thing to show you as a quick comparison between while loops and recursion. So what I'm doing is I'm commenting out this this blast off, my while loop version of it, and this is a recursive version of it. So it runs the exact same way. 10, 9, 8 all the way down to 0, blast off. The difference is, well, I'm going to punch in something high like this, 60,000. And we get what typically happens if you have a recursive statement that got out of hand. It's a stack error. There it is, stack overflow error. Too many stacks, too many copying and pasting of a method. We ran basically out of memory. You know what doesn't have that problem? While loops. So same deal here, 60,000. Do the whole thing. It doesn't care because it's not copying and pasting. It's not setting aside more memory for more methods. It's just doing it again. So if you happen to run into a situation where you have a problem where it just needs to run an excessive amount of times, I'm sure they're out there, the while loop might be more appropriate because the recursion does have that limitation where you can only do so many. Anyway, that's that, and bye.